Unfortunately, in our system of government, the vice president is like the Queen of England. You can't even get airline tickets without talking to somebody like me.
The other type of angles that we look at, which are formed within a circle, are angles formed by intersecting chords. Now remember, a chord is just a line segment which connects 2 points on a circle. So one chord here would be AB, connecting 2 points on the circle, and another chord here would be chord CD. Now it turns out that the measure of the angle formed between these two chords is equal to the average of the arcs intercepted by the angle and its vertical angle. So what that means is, if I was to look at what the measure of angle AEC is this angle right here. The measure of that angle is equal to the average of the arc it is intercepting and the arc that its vertical angle is intercepting. So I'm going to say the measure of arc AC plus the other one is BD, the measure of arc BD over 2. This angle is the average of those two arcs. Similarly, if I wanted to know what BEC was, BEC is this angle. I'm looking for the measure of this angle. It would be the average of the arc directly across from it and the arc directly across from its vertical angle. So that would be the measure of AD plus the measure of BC all over 2. So let's see a couple of examples of that. First, I tell you that the measure of arc AD is 100 degrees. Now, one thing I recommend when you're doing questions like this is to have either highlighters or colored pencils, because it can help you in highlighting what arcs you're talking about. So I'm going to highlight arc AD, and I'm going to label it 100 degrees. I also know that BC is 68 degrees. And I ask for the measure of angle BEC. So BEC would be this angle, and I'll label that X. Well, the measure of this angle, X, is equal to the average of the arc across from it, which is my 68, and the arc across from its vertical angle. And the angle vertical to X is AED, and the arc across from that is the 100 degrees. So the average of those two values is their sum divided by 2, which gives me 168 divided by 2, which gives me 84 degrees. Scrolling down to my second example, we can also use this process in reverse to solve for missing arcs. So for example, if the measure of arc AC is 56 degrees, AC is this arc, it's 56 degrees, and the measure of angle AEC is 80 degrees, I need to find the measure of BD, this arc. So I'll call that X. Well, according to the relationship I've already stated, the measure of an angle, in this case AEC, is equal to the average of the two arcs. The two arcs in this case are 56, and the one across from its vertical angle is X. So I'm going to have to sum up X, the measure of the first arc, and 56 and divide by 2. So the reason that the variable x in this case is showing up on this side of the equation is it's the measure of one of the two arcs. It's always the angle is the average of the arcs. So my two arcs are 56 and x. The average of those two things will equal my angle, which is 80. When I go to solve this equation for x, I'm going to start by multiplying both sides by 2. If I multiply both sides by 2, my 2's will cancel out on this side. That way I don't have to deal with the fraction. 2 times 80 is 160 equals x plus 56. Then I'll just subtract 56. Just a little bit of equation solving so that I get x is equivalent to 160 minus 56, or 104 degrees. Okay.